Imagine walking into a really high-end car dealership, right?
I'm picturing it.
And you drop the equivalent of a month's rent on this brand new cutting-edge luxury sedan.
Naturally, you'd expect perfection for that kind of money.
Exactly.
Yeah.
But you turn the key and you discover the manufacturer has entirely swapped the brake and the gas pedals.
Oh, wow.
And they did it on purpose. In the name of, like, logical design, they decided the brake should be on the right because B comes before G in the alphabet.
That is just a recipe for a disaster.
Right. It doesn't matter how premium the leather seats are, you are going to crash that car before you even leave the lot.
You really are. I mean, the physical friction of that moment, the sheer panic when your body executes a learned reflex and the machine responds with the exact opposite of what you intended.
Yeah.
It's one of the most jarring experiences a human being can have with a piece of technology.
And in 1985, an entire generation of office workers experienced exactly that phenomenon. Not with a luxury car, but with the most important piece of professional software on the planet.
They certainly did.
So welcome to the deep dive. Today, we're looking at a fascinating piece of source material. It's a comprehensive software review from a 1985 issue of Personal Computer World magazine, written by Kathy Lang.
A really incredible primary source.
Yeah, it is. We're using her detailed technical review to dissect the highly anticipated, heavily debated, and ultimately infamous release of MicroPro's WordStar 2000.
And to truly grasp the stakes of this review, we have to establish the computing landscape of 1985.
Please do, because it's so different from today.
It really is. WordStar was not simply a popular program. It was the absolute, undisputed king of word processing.
It defined the entire category.
Exactly. But it was also incredibly polarizing. Kathy Lang captures this perfectly in her opening paragraphs.
Yeah.
She notes that while most power users swear by it, a substantial proportion swear at it.
I love that line. So our mission for this deep dive is to explore that treacherous, tightrope walk of software development.
Right, the tension between innovating to attract completely new users and utterly alienating the hardcore power user base.
The very base that made your product an industry standard in the first place. WordStar 2000 is basically the ultimate historical case study of software update friction.
It really is.
Yeah.
Because MicroPro wasn't just deploying a routine patch. WordStar 2000 was a ground-up rewrite.
Like, completely from scratch.
Yeah, an entirely new product built specifically for the architecture of the IBM PC. They were attempting this massive paradigm shift in user interface design.
They saw the writing on the wall, I guess?
They did. They knew the era of the complex, intimidating command line interface was ending. And the era of user-friendly computing was just dawning. So they wanted to build a bridge across that gap.
I want to stop right there for a second, because before we can critique the UI choices or, the technical bugs, we must establish the literal financial cost of entry into this new digital world.
Oh, the economics are wild.
We really have to look at the economics of 1980s software. When you understand the price tag, the psychological stakes of every single software crash or confusing menu suddenly make total sense.
They do, because the modern consumer framework for software value simply does not apply here.
Not at all.
We live in a world of free ad-supported downloads, or maybe a $3 monthly subscription. In 1985, software was a major capital expenditure.
The numbers in Lang's review are just eye-watering. In 1985, the full package of WordStar 2000 cost £440.
Which was a fortune.
It was. And an upgrade for an existing WordStar user was £200. We ran those numbers through our inflation adjustments based on the source data, and in 2026 money, that full price is the equivalent of approximately £1,380.
That is just staggering for a single application.
Right. And the upgrade alone sits at around £627.
When a business spent the equivalent of £1,380 on a piece of software, it bypassed middle management completely. It went straight to the accounting department.
Wow.
Yeah, it was evaluated as a fixed asset. It was categorized the exact same way the company might evaluate the purchase of an industrial forklift or a fleet vehicle.
But help me understand the justification here. Because if I'm spending £1,380 today on a single app, it needs to practically read my mind and do my taxes.
Right.
How did any software company in 1985 convince a business to drop that kind of capital on a word processor? Could a glowing screen and a floppy disk actually replace that much physical labor?
Well, you have to picture the physical reality of an office before word processing took over.
Okay, paint the picture for us.
Imagine the sheer volume of analog tool and manual labor required to produce a single 50-page legal contract. You had a secretarial pool working on IBM Selectric typewriters.
Right. Very clunky.
Very. And if a lawyer wanted to insert a new paragraph on page 4, the secretary couldn't just hit enter to push the text down. They had to physically retype page 4, page 5, page 6.
All the way to page 50.
All the way to page 50.
Yeah.
You had physical carbon paper for copies, adding machines for tables, massive physical dictionaries on desks.
Filing cabinets taking up expensive commercial real estate.
Exactly. And tubs of Tip-X whiteout everywhere.
So the software isn't just a writing tool. It is an office consolidation tool.
Precisely. WordStar 2000 promised to absorb the entire physical infrastructure of a secretarial desk into a single IBM PC.
That makes more sense.
Yeah, Lang's review specifically calls out the inclusion of a built-in calculator for doing arithmetic natively inside the document.
Oh, that's handy.
Very. Plus, simple windowing to cross-reference multiple texts without needing massive desk space, on-the-fly spelling correction, and really complex mail merge facilities.
So you are paying top dollar because this software dramatically increases the output volume of a single employee.
Exactly.
But that sets up a terrifying dynamic for the end user. Think about the psychological pressure on the office worker who has just been handed this system.
Must have been immense.
The company just spent a small fortune on this premium tool, which means the expectation from management is immediate, flawless productivity.
Zero downtime allowed.
Right. Any friction, any steep learning curve, any confusion over a hidden menu isn't just a minor annoyance, it is a massive financial liability.
Lang actually acknowledges this pressure in her conclusion. She states that despite the hefty price tag, the inclusion of those advanced facilities made it well worth the cost for new buyers.
New buyers being the key phrase there.
Yes. The raw utility justified the financial shock for them.
But if you are a veteran secretary or a dedicated writer who has already spent the last 4 years mastering the original WordStar, the absolute last thing you want is a mandatory update that completely changes the language you use to communicate with the machine.
Yeah, you'd hate it.
Which brings us to the core controversy of WordStar 2000, the muscle memory crisis.
This is where MicroPro's ambition fundamentally clashed with human neurology.
The keyboard shortcuts in the original WordStar were legendary for being incredibly difficult to learn, but, incredibly powerful once mastered.
Very true.
Let's look at the specific example Lang highlights, the command for block movements. If you wanted to highlight and move a chunk of text in the original software, you use the shortcut sequence starting with Ctrl+K.
Which, to a complete novice, seems like absolute nonsense. Why K for a block of text?
But to a power user, that didn't matter at all. They had Ctrl+K etched into their central nervous system.
Yeah, it was an instinct.
But when WordStar 2000 shipped, MicroPro completely revamped the command sequences. Ctrl+K was dead. Block movement was now activated by sequences beginning with Ctrl+B for block.
Because the developers looked at Ctrl+K and said, well, this is hostile to new users. Let's make it logical. B stands for block. P stands for print.
Sure.
This will make the software infinitely easier to discover and learn.
I mean, I understand the logic on a whiteboard. But going back to my car analogy, it doesn't matter if you organize the pedals alphabetically.
No, you're fighting deeply ingrained physical conditioning.
Exactly. Let's talk about the mechanics of muscle memory here, because I don't think modern software developers always respect how physical our relationship with software really is.
Think of it like playing a complex chord on a piano. When a concert pianist sees a C minor chord on sheet music, they do not consciously think, I need to place my thumb on C, my middle finger on E flat, and my pinky on G.
Right, that would be way too slow.
Exactly. Their brain perceives the symbol, and their hand instantly forms a physical claw shape and strikes the keys. The cognitive load bypasses conscious processing entirely.
The shortcut is the chord.
Yes, for a true WordStar power user, their fingers never had to leave the home row of the keyboard.
Wow.
They could edit, format, move paragraphs, and save documents at the absolute speed of thought. They weren't thinking about the software interface. They were thinking purely about the content of their document.
Lang explicitly warns in her review that long-standing users will have some unlearning to do. And as anyone who has tried to break a bad habit knows, unlearning is astronomically harder than learning from scratch.
It's so painful.
You have to actively consciously suppress a physical reflex you've relied on thousands of times.
This is the eternal battle in UI design. Discoverability versus efficiency.
And MicroPro bet the farm on discoverability.
They did. They wanted a novice to sit down, press Ctrl+B, and then see a helpful visual menu pop up explaining what to do next. But by leaning into phonetic shortcuts and visual menus, they deliberately destroy the efficiency of their loyal base.
And sometimes the new logical sequences weren't just unfamiliar, they were objectively slower and more cumbersome.
They really were.
Lang provides a great example in the review. If a command wasn't assigned to one of the new dedicated function keys on the IBM keyboard, it required chaining long strings of inputs together.
Right.
Turning off block highlighting in the old system was a rapid two-key flick. In WordStar 2000, it now required pressing 3 distinct separated keys. Ctrl+B, wait for the menu, then press D.
And just like that, you've completely shattered the user's flow state. You've forced them to stop thinking about their writing, look down at the keyboard, look up at a menu, and consciously execute a multi-step navigational task.
But wait, from a software engineering perspective in 1985, why was this an either situation?
What do you mean?
Well, why couldn't MicroPro just include a classic mode toggle? Keep Ctrl+B for the new users, but let the veterans check a box in the settings to keep Ctrl+K active.
That is a brilliant question, and it reveals the severe hardware constraints of the 1980s. Modern software has the luxury of gigabytes of RAM and massive hard drives.
Right, we take that for granted.
We do. It allows developers to ship massive code bases that include multiple redundant interfaces. But in 1985, WordStar 2000 was shipping on physical floppy disks holding roughly 360 kilobytes of data each.
Wow.
And it was running on computers with maybe 256 kilobytes of system memory.
Ah, so every single line of code is precious real estate.
Exactly. Programming a robust dual-input parser that constantly listens for 2 completely different sets of command structures across the entire application would consume massive amounts of memory and processing power.
They just didn't have the space.
They physically did not have the overhead to support both paradigms. They had to choose one, and they chose the new user.
And that choice creates a massive amount of psychological friction. If we compare this 1980s interface change to how modern software updates frustrate current users, the parallels are just incredible.
Oh, absolutely.
How often do modern tech giants completely redesign an interface, bury a core feature in a nested menu, or change a universal navigation paradigm in the name of a cleaner aesthetic?
The modern software as a service model actually exacerbates this. With cloud-based software like Google Docs or Microsoft 365, the interface can change overnight without your permission.
That is so frustrating.
You open your laptop on a Tuesday, and the button you've clicked every day for 3 years has vanished, replaced by an ambiguous icon hidden in a drop-down menu.
And the software developers, they look at their telemetry data and say, well, A/B testing shows that new users find this nested menu 12% more intuitive.
Right.
Meanwhile, the millions of existing power users are screaming at their monitors because a task that took half a second now takes 3 clicks and a visual search.
Exactly.
The emotional betrayal, the feeling that your tools are suddenly fighting your hands, it's identical, whether you are using an IBM PC in 1985 or a MacBook in 2026.
And that friction in WordStar 2000 wasn't just limited to the keyboard shortcuts fighting the user's hands. The software also began to fundamentally clash with the physical hardware sitting on the desk.
Oh, this is the best part.
It really is. This brings us to one of the most technical and revealing flaws in Lang's review, the 12-pitch nightmare.
This segment of the review is a masterclass in the growing pains of early word processing. It perfectly illustrates how poor hardware integration can completely ruin the software experience.
It really does.
So let's break down the technical mechanics of the 12-pitch issue. What exactly is happening here?
It fundamentally comes down to how a software program attempts to create an illusion. The goal of a word processor is to represent a physical, printed piece of paper on a digital cathode ray tube monitor.
Right.
So to help users align their text, set tabs, and manage margins, WordStar 2000 featured an on-screen visual ruler across the top of the document.
Just like a digital measuring tape.
Right. However, this ruler was hard-coded into the software to measure the screen in tenths of an inch.
Which operates on the assumption that every single character you type, a W, a period, is exactly 1/10 of an inch wide.
Correct. That mechanical standard is known as 10-pitch, meaning 10 characters fit into 1 physical inch of paper.
Okay, got it.
In the United States market, 10-pitch was the dominant default for commercial typewriters and printers. So for a U.S. user, everything worked flawlessly. The characters rendering on the screen aligned perfectly with the tick marks on the digital ruler.
But Kathy Lang is writing for a UK publication, addressing a European market.
And in the UK, the common formatting standard for business documentation was 12-pitch. The text was slightly smaller, denser, fitting 12 characters into an inch.
So what happens when a British office worker, relying on their standard 12-pitch physical printer, boots up this 1,380-pound piece of American software?
Complete visual breakdown. The software's on-screen ruler stubbornly remained divided into tenths of an inch, but the text beneath it was trying to simulate a 12-pitch layout. Because the scaling didn't match, the characters on screen completely decoupled from the ruler.
That's a disaster.
Lang vividly describes how if you set your right margin at 60 characters, the text on the monitor would literally extend far beyond the 6-inch mark on the visual ruler to occupy the correct number of character positions.
That sounds absolutely agonizing. The visual feedback loop of the software is effectively lying to the user's face.
In computer science, we call this an abstraction leak. The software is trying to maintain the abstract illusion of a physical page.
But it fails.
Exactly. Because the developers failed to make the user interface dynamically adjust to match the hardware output, the illusion shatters. The user suddenly sees the chaotic, mismatched mathematics underlying the system.
Wait, I need to understand the why here.
Okay.
If I change my font size or pitch in a modern word processor today, the ruler at the top of the screen just instantly scales to match. Why was the WordStar ruler hard-coded? Was it just sheer laziness from the MicroPro developers?
Not laziness, but a desperate attempt to save precious CPU cycles. You have to understand how early MS-DOS graphics rendered on a CRT monitor.
Okay, lay it on me.
It wasn't drawing smooth vector graphics like we have today. The screen was essentially a grid of rigid memory blocks, usually 80 columns wide by 25 rows high.
Yeah.
Dynamically redrawing and scaling a visual ruler required floating point mathematics.
Calculating fractional widths in real time as the user typed.
Exactly.
And early 80s processors were terrible at floating point math without a dedicated math coprocessor.
Exactly. It would have caused the entire program to lag every time you pressed a key. So the developers took a shortcut. They hard-coded the ruler to map one-to-one with the rigid memory grid of the screen, assuming 10 pitch.
They traded flexibility for performance.
They did, and in doing so, they completely abandoned their international users.
Lang notes that the line breaks would still actually print correctly on the physical page, which, in a way, makes the problem worse.
How so?
Because it means you cannot trust your own eyes while editing on the screen. She specifically points out how this made setting up complex tables an absolute nightmare.
Imagine trying to align 3 columns of financial data when you cannot use the ruler above the text to visually check your tabs.
She details the manual labor required to bypass this software failure. She suggests you had to revert to mathematically calculating your tab spaces on scratch paper.
Scratch paper. While sitting at a computer.
Right. Or typing out the absolute longest line of your table first, manually spacing it out with the space bar, and then building the rest of the table around that template. That is so primitive.
It really is.
We are talking about a machine designed to automate formatting, and it's forcing users to manually count spacebar taps.
And the disconnect between the software's capability and the hardware's reality didn't stop at the screen. It extended directly to the physical printers themselves. We need to discuss how WordStar 2000 artificially nerfed the era's premium printing hardware.
The daisy wheel printer.
Yes.
A daisy wheel printer, for context, is essentially a rapid-fire mechanical typewriter controlled by a computer. It has a physical wheel with letters on the ends of little plastic arms pedals that spin at high speed and strike an ink ribbon against the paper.
And mechanically, high-end daisy wheel printers in 1985 were engineering marvels. They contained incredibly precise stepper motors capable of varying the vertical line height of the paper by 1/48 of an inch.
That is incredibly precise.
They offered micro adjustments for perfect typography.
But WordStar 2000 didn't let the user access that precision. Lang writes that despite the hardware's capability, the software artificially restricted the user to rigid, predefined choices of 2, 3, 4, 6, and 8 lines per inch. But from a developer's standpoint, building a cage to restrict features actually takes more coding work than just passing the raw variables directly to the printer. Why would MicroPro spend expensive engineering hours just to put handcuffs on the hardware?
It all rotes back to the terror of feature bloat and their absolute obsession with the novice user.
Of course.
In 1985, UI designers hadn't perfected the concept of nested advanced settings menus. Today, if you want to tweak kerning by a fraction of a millimeter, you click an Advanced Options tab that hides the complexity from average users.
Out of sight, out of mind.
Exactly. MicroPro didn't have that elegant design language yet. They made a paternalistic decision. Giving a user the option to adjust spacing by 1/48 of an inch requires a massive, intimidating menu of numbers.
So they just cut it.
To prevent the novice from feeling overwhelmed, they simply amputated the functionality entirely.
They catered to the lowest common denominator, effectively punishing the power users who knew exactly what their expensive printers were capable of. It's wild to think about software actively suppressing the hardware sitting right next to it.
It is a bizarre historical quirk.
But speaking of hardware and this intense reliance on physical, mechanical workflows, WordStar 2000 included one bizarre feature that explicitly tried to turn this 1,380-pound piece of digital cutting-edge software back into a clunky mechanical machine.
Oh, yes.
We have to talk about Typewriter Mode.
This is one of the most fascinating psychological artifacts in the entire history of computing.
Typewriter Mode. As the name implies, this feature allowed the user to bypass the entire concept of saving and formatting a digital document. Whatever you typed on the computer keyboard was echoed directly, instantaneously to the printer.
One key press, one print.
Exactly. It would print either one character at a time or one line at a time, exactly like you were sitting at a standard mechanical typewriter. You aren't creating a file. You are just blindly hitting keys and watching ink hit paper.
Which completely nullifies the entire value proposition of a word processor.
Right.
The whole point of digital text is the ability to edit, backspace, rethink, format, and save a perfect copy before committing it to physical paper.
Kathy Lang's take on this is absolutely hilarious and appropriately mocking. She writes that she can't imagine any self-respecting typist needing that much reassurance of the friendliness of the word processor.
She understands the office politics perfectly. She hypothesizes this mode was explicitly demanded by the sales teams.
Oh, that makes sense.
Right. They needed a feature to sell this intimidating software package to older, traditional managers who believed their timid secretaries would be terrified of the digital screen.
It's the equivalent of buying a maxed-out iPad Pro today and exclusively using it as a digital picture frame to display a single static photo of your dog on your desk. You possess incredible processing power, and you're treating it like a glorified piece of stationery.
It seems absurd to us, but we have to elevate this beyond a funny anecdote.
Okay.
Typewriter mode is a profound example of a concept called skeuomorphism, acting as a psychological bridge.
Skeuomorphism. That's when a new technology retains the ornamental design cues of the older technology it replaces. Like how the save icon on your computer is still a picture of a floppy disk, even though nobody has used one in decades.
Exactly. Or how early digital calendars had fake leather stitching rendered on the screen. Typewriter mode was a functional skeuomorph. We have to empathize with the profound anxiety of the 1985 office worker.
They were used to paper.
They were transitioning from physical paper, something you can touch, hold, and trust completely, to a glowing digital abstraction rendered on volatile RAM.
Volatile RAM, meaning if someone trips over the power cord or the software crashes, everything you just typed simply ceases to exist. It vanishes. A piece of paper never crashes.
That anxiety was paralyzing for early adopters. Human brains panic when stripped entirely of physical context. Software companies had to over-engineer these backwards-looking regression features just to coax anxious users into the digital age.
A safety blanket.
Yes. Typewriter mode was a way for the machine to whisper, "Don't panic. If this digital illusion is too scary, I can still just be a regular dumb typewriter. I won't lose your work."
Lang, ever the pragmatist, does concede a tiny sliver of utility for it. She notes it might actually be useful for typing up very short one-off memos or addressing an envelope, just to avoid the hassle of opening a new file, saving it, printing it, and then subsequently having to manually delete that file to conserve precious, limited floppy disk space.
Which again reminds us of the severe physical constraints. Storage was not a bottomless cloud. It was a fragile magnetic disk that could fill up after a few dozen pages of text.
So we've painted a fairly grim picture. We've analyzed the massive economic cost. We've dissected the infuriating betrayal of the power users through changed muscle memory shortcuts.
We really tore it apart.
We did. We've explained the hardware mismatches with the 12-pitch ruler and the Nerf daisy wheels and explored the psychological crutch of typewriter mode. But if we stop there, we are doing a massive disservice to the history of software engineering.
Absolutely.
For all its flaws, WordStar 2000 introduced genuinely groundbreaking tools. These are features that quite literally revolutionized how humans interact with text. We need to dedicate serious time to the miracle features.
It is vital to recognize what MicroPro accomplished here. because the ambitious features they forced into this software became the absolute bedrock of modern computing.
We have to start with the undo command. Lang specifically highlights this in her review, calling it a lifesaver.
A total game changer.
For anyone listening who grew up reflexively hammering Ctrl+Z every time they make a typo, it is almost impossible to fathom a digital environment where deleting a paragraph was a permanent, irreversible act of destruction.
The technical implementation of an undo feature in 1985 is staggering when you consider the memory constraints we just discussed. To offer an undo command, the software must secretly allocate a dedicated portion of that tiny 256 kilobyte RAM block to hold a complete copy of the previous state of your document.
It has to remember the past.
Right. It is actively recording history in the background.
It's a massive resource hog.
It is. But the psychological relief it provided was revolutionary. Undo transformed writing from a high-stakes, stressful act of precision into a fluid, forgiving process of experimentation.
You were allowed to mess up.
You were suddenly allowed to make mistakes. You could take creative risks with your formatting, knowing you had a safety net. That feature alone likely justified the upgrade price for thousands of anxious typists.
And the miracles of productivity didn't stop at the safety net. WordStar 2000 took a massive leap toward what we now call WYSIWYG. What you see is what you get.
Such a great acronym.
The software featured automatic reformatting on the fly and crucial on-screen emphasis. You could actually see your bolding and underlining rendered visually on the CRT monitor as you typed.
Which doesn't sound like a miracle until you understand how the original WordStar handled formatting. In older command-line word processors, you didn't see bold text. You saw a control code.
Like programming.
Exactly. If you wanted the word warning to be bold, it looked like "B," warning "B" on the screen. The text was buried in a chaotic mess of markup tags, making it incredibly difficult to proofread for visual flow.
Why did it take so long to get visual formatting?
Because of the computational overhead. Rendering control codes as raw text is easy for a processor. Actively intercepting that code, analyzing the font matrix, and commanding the CRT monitor's electron gun to strike the screen with higher intensity to create a bold pixel requires significantly more real-time processing power.
They were pushing the limits.
MicroPro pushed the IBM PC hardware to its absolute limit to provide that visual comfort.
The review also highlights the incredible utility of Windows. And to be clear, we are not talking about Microsoft's operating system here. We are talking about the windowing feature native to WordStar 2000.
Right, internal software windows.
It allowed a user to view sections of up to 3 different documents simultaneously on a single screen and seamlessly copy blocks of text between them.
This is another feature that requires deep historical context to appreciate. If you think about the physical analog equivalent of that task, having 3 separate paper reports spread out across a large wooden desk, physically cutting a paragraph from one page with a pair of scissors and using tape to stuff it to another page. The digital windowing feature was akin to sorcery.
It fundamentally altered the velocity of business. You could assemble complex legal briefs or corporate reports from boilerplate templates in minutes instead of hours.
But the true technical masterpiece mentioned in Lang's review is the background printing.
Yes, explain this one.
Lang points out that you could be actively typing and editing one file on your screen, while the software was simultaneously sending another file to the printer in the background, with no noticeable effect on keyboard activity.
I read that and immediately thought, wait, that makes no sense. MS-DOS, the operating system running these machines, was strictly a single tasking environment.
Right.
It fundamentally only allowed the processor to execute one command at a time. How on earth did WordStar 2000 achieve background printing?
They used incredibly complex programming tricks called terminate and stay resident, or TSR, programs, combined with hardware interrupt requests. Essentially, WordStar was micromanaging the CPU.
Okay.
It would let you type a character, and in the fraction of a millisecond between your keystrokes, it would hijack the processor, squirt a tiny chunk of data through the parallel port to the printer's memory buffer, and hand control back to your keyboard before you even noticed.
They were effectively faking multitasking by slicing time into imperceptible fractions.
Yes, and the result maximized human efficiency. It untethered the worker from the slow mechanical pace of the hardware. You didn't have to put your hands in your lap and stare at the wall for 10 minutes while the daisy wheel clattered away. You could keep working.
There are a few other touches that feel incredibly modern, too. The inclusion of automatic footnotes, which dynamically renumbered themselves if you inserted a new citation in the middle of a document.
Oh, academics must have wept with joy.
Lang notes this was invaluable in much academic writing. No more erasing and renumbering 50 footnotes by hand because you forgot one reference in Chapter 2.
It marks the critical transition where the software begins doing the tedious administrative labor for you, rather than just acting as a digital canvas.
I also have to mention the color customization. Lang had a minor critique that the embedded visual rulers defaulted to the exact same color as the standard text, which caused visual clutter.
A fair point.
But the mere fact that you could dive into the settings and map specific UI colors, choosing different terminal colors for bolded text for menus for the rulers, was a huge step forward for ergonomics.
Staring at a high-contrast monochrome green or amber CRT screen for 8 hours a day caused severe eye strain. Giving the user the agency to customize the color palette shows a maturing understanding of human-computer interaction. They are designing for human comfort, not just machine efficiency.
But of course, MicroPro couldn't resist injecting a bit of absolute chaos amidst all these miracles. I have to highlight a glaring, almost comical UI flaw that Lang points out regarding the keyboard layout.
Oh, this is a classic.
When you were done editing and ready to leave a document, you had options to save your work. But the function key assigned to abandon your changes and exit without saving was placed physically right next to the save key on the PC keyboard.
From a purely ergonomic perspective, that is genuinely terrifying interface design.
That makes zero sense. It's exactly like installing the self-destruct button right next to the volume knob on the dashboard. One slight slip of the pinky finger, and hours of meticulous typing are vaporized.
I'm sure people lost entire chapters of books to that key layout.
Yes, the software asked for a confirmation, but we all know the psychology of dialog boxes. When we are in a hurry to leave the office at 5 p.m., we blindly hit yes to whatever pops up on the screen.
It proves that while MicroPro was incredibly ambitious in their software engineering, their understanding of physical user experience design was still in its infancy. They hadn't learned the concept of creating physical friction for destructive actions.
So bringing all of this rich, chaotic history together, how do we evaluate the final legacy of this ambitious, flawed, and incredibly expensive software?
Well, WordStar 2000 stands as a fascinating monument to the painful realities of technological progress. It was an incredibly powerful tool that dared to look forward.
A bit stumbled along the way.
It did. In doing so, it deeply alienated its core base by shattering the physical muscle memory shortcuts they relied upon. It struggled to smoothly integrate with the physical reality of 1980s hardware, leading to the agonizing 12-pitch abstraction leaks and handcuffed printers.
Right.
Yet, beneath those flaws, it pushed the entire industry forward by engineering absolute essentials. Things we fundamentally cannot live without today, like the memory-intensive undo button, brilliant WYSIYG formatting, and the technical sorcery of background printing on a single-tasking OS.
It is the ultimate story of technological growing pains. And for you listening, I want you to take this perspective with you. The next time your modern cloud-based software updates overnight, the next time your favorite app arbitrarily changes your favorite shortcuts or moves a critical navigation menu to a place that makes absolutely no logical sense to your workflow, just know that you are experiencing the exact same frustrating unlearning curve that office workers felt in 1985.
It's the exact same feeling.
The battle between accommodating the complete novice with discoverable menus and respecting the loyal power user's efficiency is as old as personal computing itself. We have been fighting this exact same war for 40 years, and the psychological friction never changes.
And as long as interfaces continue to evolve, we will keep fighting it. The tension between human neurology and software design is permanent.
Which brings me to a final, slightly provocative thought for you to mull over. We've spent this entire deep dive talking about the massive disruption caused by simply changing a keyboard shortcut from Ctrl+K to Ctrl+B.
Just a single keystroke change.
We've seen how deeply ingrained our physical neurological connection to our digital tools becomes. Our fingers learn the chords. So what happens to us in the next decade as artificial intelligence begins to completely remove the keyboard and the mouse from the equation entirely?
That's a huge question.
When we no longer type commands, but simply speak our vague intentions to an AI agent that drafts, formats, calculates, and publishes for us, will we feel liberated from the tyranny of the keyboard? Or will we grieve the loss of the physical control, that satisfying, lightning-fast digital muscle memory that we spent our whole lives mastering? Because at the end of the day, when the interface completely vanishes and the machine does the driving, who is really in control? You or the machine? Think about that the next time you reflexively reach for a button that is no longer there.